Hello everyone, in this video I will show you how to answer a question that asks us to determine the convergence of a certain series using the comparison tests. So here I will be using this example where the series sum goes from n equals 1 to infinity, and we have the terms square root of n plus 1 divided by 2n squared minus 1. If we take a look here at the comparison theorem, it tells us that we have a certain series an, which is the given series usually, and then we have another series bn. And as long as those two series are positive, we can divide an by bn and get the limit of as n goes to infinity, and that's going to give us a certain number a. And we check this number a. If it's positive, then we can say that we can conclude that the series of an and series of bn have the same convergence behavior. So if bn converges, then an will also converge, and if an converges, then bn will also converge. So if we look at the example that we have and try to do it, this is our an. Then the steps we take to solve a question like this is, well, firstly, we have to choose a bn because we have to have some kind of bn to compare the an to. So how do we choose a bn? Well, the way to choose a bn is basically just to look at this an and think, what does this expression behave as when n is a really large number? So when n becomes a super large number, not 100, not a million even, but think about trillions and billions. What does this behave as? Well, when n is a really large number, then the square root of n is still a very extremely large number, and this 1 doesn't really matter that much because just adding 1 to a trillion doesn't really is not really that significant. So we can take that square root of n here, and we can say that that's our numerator for bn. And down here we do the same thing. When n is really large, this minus 1 doesn't really matter. Even this times 2 is not really that significant. But n squared, if say we have a trillion, then that's a trillion trillions, and that's really large. So we can put n squared here. And this is our bn. So this just equals 1 over n to the power of 3 over 2 if you do the if you subtract the powers. So this is our bn. 1 over n 3 over 2. That's it. The second step that we do is to determine the convergence of the series of bn. Well, we have to tell whether this bn converges or diverges. And then we have this rule that says that if you have a series of 1 over n to the power of alpha, then this series is going to converge when alpha is larger than 1, and it will diverge if alpha is less than or equal to 1. And in this case, as you can see, our bn has an alpha which is 3 over 2, and 3 over 2 is larger than 1, so we have that the series of bn converges. Right, so now we've done 2 steps, and we're gonna be done soon. Basically now we have bn is the terms of a series that is very similar to an. We sort of studied how an will behave at large numbers, and we got our bn, and this converges. So we expect and we think that an will also converge, but we have to prove that mathematically. We can't just guess. And the way to prove that is through the theorem. We take this limit of n goes to infinity of an divided by bn, and if we get a number that's positive, then we have confirmed that and we have proven that they behave the same. So let's do that. The next step would be to do this calculation. So number 3, we take the limit as n goes to infinity of an divided by bn. And this is the same as we take our an, which is square root of n plus 1 divided by 2n squared minus 1, and we divide it by our bn, which is 1 over n to the power of 3 over 2. In these cases, when you have a division like this, you just multiply the bottom with the top. So n 3 over 2 times square root of n plus 1 divided by, and then the middle ones multiplied together, which is 2n squared minus 1 times 1, so it stays the same thing. And here we just multiply this in, and we get n squared plus n 3 over 2 divided by 2n squared minus 1. Because here you just plus the powers, and 3 over 2 plus half is 2, and then this one is just multiplied by 1. At this stage, we want to factor out the n squared, so to simplify this expression. So we always look at the biggest number that's common, that's both on top and on the bottom, and that's n squared here. And we just factor it out, so we get n squared, and we open parentheses, and we put here n squared, and we open another parentheses. And basically, we just look at, we're just multiplying by n squared. So we just have to divide by n squared again. So we look at all these terms and divide them by n squared. So here we get n squared by n squared, which is 1, plus n squared divided by n 3 over 2, which is going to give us 1 over square root of n. And here we divide by n squared gives us 2 minus 1 over n squared. Great. And now we can just take out the n squared. And now we can take the limit to this. So if we say, what does this behave as the limit of n reaches infinity? So when it becomes a really large number, again, what does this expression become? And then we look, well, when n is a really large number, then 1 divided by n, this goes towards 0. And when n is a really large number, again, 1 over n squared is going to become closer and closer to 0. Because here you have, if n is 10, then you get 0.1. If it's 100, you get 0.01. But so it gets smaller and smaller, closer to 0, as big as n gets. And when n is a trillion, then square root of n is still a larger number, and still you're very close to 0. So what are we left with here? We're just left with 1 over 2. 1 over 2. And that's great, because 1 over 2 is just our a here. Right? Because we just did the limit of a(n) over bn, a, which is positive. So we do have an a that is positive, and we can confirm. That means that we can say that the series of an and the series of bn behave the same with respect to convergence. And we know that bn converges, so that means that an should also behave the same as bn, and so it should also converge. So this is a convergent series, and that's the answer to our question. If you're doing this in an exam, though, these are the 3 main steps, but the 4th step, which can earn you a mark, is to just write something like this here, just for the logical sort of follow-up to show that you understand how this works. So you say half is bigger than 0, therefore the series of an and bn behave the same with respect to convergence, and since the series of bn is convergent, our given series of an is also convergent by the comparison theorem or comparison test. And then you will get a full mark, hopefully. So I hope you have understood the main steps of how to find if a series is convergent. This is not a hard one, but not an easy one either. This was an exam that I had previously in my first year of math at college. So it's a standard kind of one. So I'm going to give you another one for you to do, which is quite similar, yet kind of different. And hopefully you will use these steps and be able to determine the convergence successfully. So we have a series, it's very similar, square root of n plus 1, but here we have 2n minus 1. Originally, in the one we did, it was n squared, but this was n minus 1. And you will find the answer in the description. Try it out first, try your steps here, and find whether it converges or diverges, and then look at the answer, and if you need help, just ask in the comments. Okay, thank you.